Hello everyone, I welcome you to another interesting edition of the mathematics class. If you can recall very well, in the last class we stopped at the concept of addition and subtraction of number base. And today we want to talk about multiplication as well as the division of number base. So to start with, I have some examples that we are going to work over. So in number 1, so we have 101 multiplied by 1. So we can see everything here is in base 2. So doing this is normal multiplication, just like we multiply normal number. So 1 times 1 here gives 1. 1 times 0 here gives 0. 1 times 1 here gives what? 1. So the second level, 1 times 1 here gives 1. 1 times 0 here gives 0, and 1 times 1 here gives 1. And we know quite alright that after multiplication like this, what follows up is what? We are going to add the two results which we have here. So since I have nothing to add with 1 here, so that has to be written as 1. And 0 plus 1 here is going to be written as 1, since the result of adding 0 and 1 gives a value not up to the base which we are relating with. And here as well, 1 plus 0 will also give what? 1. And finally, I have what here? I have 1. So the result of multiplying 101 base 2 by 11 base 2 gives the value of what? 1111 base 2. So that is the solution to number 1. Now in number 2, I have 1110 multiplied by 101. We can all see that everything here is as well in base 2. So multiplication is normal one. So 1 times 0 here gives 0. 1 times 1 gives 1. 1 times 1, 1. 1 times 1, 1. So move over to the next step. 0 times 0 here gives 0. 0 times 1, 1. 0 times 1, 1. And 0 times 1 here gives what? 1 as well. And finally, 1 times 0 here gives 0. 1 times 1 here is 1. 1 times 1 here is 1. And 1 times 1 here is 1. So after the multiplication comes what? The summing of the results which we have so far. So here is going to be written as 0. Remember, this is going to be base 2. Here I am to add 1 and 0. We know the result that gives is what? 1. And here 1 plus 1 plus 0 is what? 2. And if you can recall from what we learned in the last lesson, we know that we are not allowed to write the 2, since the number we get here is equivalent to the base, or in situation whereby the number is higher than the base, and then such a number will have to be what? To be treated specially in order for us to know the value which we are going to write here. So 1 plus 1 here is 2, so 2 is too big for me to be written there, so that has to be the 2 I have divided by the base which we are operating with. And 2 divided by 2 here gives 1 with the remainder of 0. So it is that remainder we are allowed to write here. Why the one which I have here will now be moved here. So the addition again, 1 plus 1 plus 1 plus 1 here gives the value of 4. So we can see the value we obtain now is also higher than the base we are dealing with as a result. So it has to be treated specially. So that will be 4 divided by 2. So 4 divided by 2 gives 2 with the remainder of 0. So we are allowed in that wise as well to put down our remainder. Why the 2 I have here will be shifted there. So I will add it once again. 2 plus 1 plus 1 also gives the value of 4. So we can see we are not as well allowed to write the 4 here. So what we rather do here is we go to this corner here to treat 4. So since I have something equivalent to that, I think it's not necessary for me to do or to carry out the division. So I will just say 4 divided by 2 is 2 with the remainder of 0. So that remainder of 0 will be written here. So the 2 which I have here will also be moved to this place. So when I add it, 2 plus 1 here gives 3. You can as well see that 3 here is higher than the base we are dealing with. So we are not allowed to write that. So what we rather do is we are going to treat the 3. So by saying 3 divided by 2, we know that gives 1 with the remainder of 1. So the remainder of 1 will have to be written here. But we didn't have anywhere to shift this number again. As a result, we put it here. So the result of multiplying 1110 by 101 base 2 gives the value of 110010 base 2. That's number 2. In number 3, What I have is 10101 multiplied by 1. So 1 times 1 here gives 1, 1 times 0 0, 1 times 1 1, 1 times 0 is 0, and 1 times 1 here is what? 1. Then the next step is 1 times 1 here 1, 1 times 0 gives 0, 1 times 1 1, 1 times 0 0, and finally 1 times 1 here gives 1. Then what follows this is what? Adding. So I have nothing to add with this, so it means 1 will have to be written. 0 plus 1 here gives 1, 1 plus 0 here gives 1, 0 plus 1 here gives 1, 1 plus 0 here is 1. Nothing to add to this one, so 1 will be written base 2. So that is what the multiplication of any two given binary numbers is all about. So right now we want to talk about division. So the first question here I have, so it will be better I place my two questions here. Then number 5, 1111 divided by 11, and here 11000 divided by 11. So we know, as you can see, that everything here is in base 2. Now to solve the question 4. Now the system of division here, there are many approaches to dealing with the division, but want to apply the easiest one. So the easiest one means we are going to convert each number given to us to base 10. So to base 10, and from base 10 we take it to base 2, and the result that gives will automatically takes it back to what? To the required base. So solving this one means I have to convert this one to base 10. So to be better, I write it in this pattern by saying 11000 divided by 1 1. We can all see everything here is in base 2. So the first step here is we want to convert what we have here to a base 10 number, and for it to be in base 10 means we have to count it, that is, we assign some values. Since everything here happens to be what? A whole number, so the assigning of value will start from the last digit, just like we did it under base 10 conversion. So this will be 0 1 2 3 4, while the one here will be 0 1. And what follows that is I will convert now to base 10. So converting to base 10 becomes this: 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 0 times 2 raised to power 0 divided by 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. So to continue with this means 1 times, we know 2 raised to power 4 here gives 16, plus 1 times 2 raised to power 3 here gives 8, plus 0 times 2 raised to power 2 here gives 4, plus 0 times, we can see that 2 raised to power 1 is 2, plus 0 times 2 raised to power 0 here is what? 1, divided by 1 times, we know 2 raised to power 1 is 2, plus 1 times 2 raised to power 0 here gives what? 1. Now 1 times 16 here is 16, plus 1 times 8 here is 8, 0 times 4 here is 0, 0 times 2 here is 0, and 0 times 1 here is 0. Everything over 1 times 2 is 2, plus 1 times 1, 1. Now when we add this place, 16 plus 8 plus 0 plus 0 plus 0, that gives 24, divided by 2 plus 1 here is what? 3. And what is the result of 24 divided by 3? That gives the value of 8. So we can say that we are done with the solution here. But because the mode of the question is that the question was given to us in base 2, so to be very necessary, we round it back to base 2 in order to give out the result. So the result in this case will be taken back to base 2. So taking this back to base 2 involves writing my 8, then I will create special column like this. So the number with the base with which we want it to be is the mode of division. So I will divide by 2 here, while any remainder I have whenever I carry out my division is going to be in this column. So I can call that one out. Now let's start the division. 2 in 4 here gives 2, 2 in 8 here rather gives 4, with the remainder of what? 0. 2 in 4 here gives 2 with the remainder of 0. 2 in 2 here gives 1 with the remainder of 0. And 2 in 1 here is 0. That one leaves the remainder of what? 1. And we're going to state our answer in up-down pattern. Therefore, the result of dividing 11000 base 2 divided by 11 base 2 is 1000 base 2. And this all completes the solution to question number 4. And finally is number 5. So what we have in number 5 is 1111 base 2 divided by 11 base 2. And just like I explained it above, I want to convert everything to base 10, and from base 10 we take the result we should get to the required base as stated in the question which we are solving. So I will have to write my question in this pattern by saying 1111 base 2 divided by 11 base 2. Since I want to convert this into base 10 means I have to assign each number there some value. So assigning of numbers, we must start from the back since we are dealing with what? A positive number. So this is going to be 0, 1, 2, 3, and this is going to be 0, 1. And that becomes 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. Everything over 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. We can say this gives, 2 raised to power 3 here is 8 plus 1 times 2 raised to power 2 here is 4 plus 1 times 2 raised to power 1 here is 2 plus 1 times 1 for 2 raised to power 0. Everything here over 1 times 2 raised to power 1 is 2 plus 1 times 2 raised to power 0 here is what? 1. So when we multiply, 1 times 8 gives 8, 1 times 4 is 4, 1 times 2 is 2, and 1 times 1 is 1. Everything here over 1 times 2 is 2 plus 1 times 1, 1. So when we add 8 plus 4 here gives 12 plus 2, 14 plus 1, 15. So we have 15 over 3. And we can see that the result of dividing 15 by 3 gives what? The value of 5. But this 5 is in base 10. Now, to represent or to give out the final answer means this result which we have here, we want it to be in what? In base 2, since the question was given in what? In that pattern. So doing that means I'm going to write my number, then I want it to be in base 2, so the division has to be done by what? 2. Then while the last column represent the remainder, each time we what? We carry out the division. And what we want to do here is that we want this number to become 0. We want to reduce it to become what? To become a 0. So, and it is the base of 2 I will use to divide it continuously until the number becomes 0. So 2 in 5 here gives 2 with the remainder of what? 1. 2 in 2 here gives 1 with the remainder of 0. 2 in 1 here is not possible. We say 0 then with the remainder of 1. And as a result, 1111 base 2 divided by 11 base 2 gives the value of what? 101 base 2. And with this, we have come to the end of everything we are expected to learn a number basis for the JSS 3 level. So what now follows is we want to solve 2 or more questions that involved combination of some of these rules, some of what we have learned so far in the number basis. So I am going to take the first question now. Now, here is one. Simplify. Root 11001. We know this thing is in base 2. So this is like we have to find the square root of a base 2 number. So what we do in the aspect of square root is that we convert this number to a base 10 number. So once it is a base 10 number, we can easily take its root. Then we can now return the result that gives back to what? To the required base, which is base 2. So doing that means I want to convert this into base 10. So converting it to base 10 will require assigning some values to this number. I can say it is equal to, I have 1 1 0 0 1 base 2 0 1 2 3 4. So that's going to be root 1 times 2 raised to the power 4 plus 1 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 0 times 2 raised to the power 1 and 1 times 2 raised to the power what? 0 there. And that is the same thing as 1 times, we know 2 raised to the power 4 gives 16 plus 1 times 2 raised to the power 3 here is 8 plus 0 times 2 raised to the power 2 here is 4 plus 0 times 2 raised to the power 1 which gives 2 plus 1 times 2 raised to the power 0, and that gives what? 1. So this becomes 1 times 16 16, 1 times 8 8, 0 times 4 0, 0 times 2 0, and 1 times 1 1, and the result this gives is 16 plus 8 here is 24 plus the 1 here is 25. So taking the square root of 25 gives what? 5 base 10, but we expect this answer to be in base 2, so we have to reduce it back to base 2. So doing that, it will involve this step. So by 5 will be written like this. So I will keep dividing it by 2 since I want it to what? To be in base 2, or for it to occur as a base 2 number. While the remainder we have each level, each time I'm carrying out my division will be kept here. So 2 in 5 here gives 2 with the remainder of 1. 2 in 2 here gives 1 with the remainder of 0, and 2 in 1 here is 0 with the remainder of 1. So we can now conclude that therefore the square root of 11001 base 2 is equal to 101 base 2. So we need to take few more examples before we finally call it a day on this topic, so that we'll be able to move over to another topic. Now what we want to talk about now is this: evaluate. We are asked to evaluate 101 base 2 raised to power 3 plus 11 base 2, everything here raised to power 4. So the pattern is the same. What we are going to do in this case is that we are going to convert each number here to what? To base 10. From base 10 we can do what we are asked to do here. Addition will follow up, and the result we get, the overall result we get at the end of the day may now be what? Converted back to base 2. So it becomes, I have 101 base 2 0 1 2 raised to power 3 plus 11 base 2, everything raised to power 4. This is 0 1. So that becomes 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0, everything here raised to power 3 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. So everything raised to power 4. That gives the value of 1 times 4 plus 0 times 2 plus 1 times 1 raised to power 3 plus 1 times 2 plus 1 times 1 all raised to power 4. And that gives 1 times 4 4, 0 times 2 0, 1 times 1 1 raised to power 3 plus 1 times 2 here is 2, 1 times 1 here is 1, everything here raised to power 4. And we can see the result of adding 4 to 0 and 1 gives 5 raised to power 3 plus 2 plus 1 here gives 3 raised to power 4. And by the basic rule or law of indices, we know 5 raised to power 3 means 5 should be repeated 3 times, like this: 5 times 5 times 5 plus, then the case of 3 raised to power 4 means 3 should as well be written how many times? Should be repeated 4 times, that is 3 times 3 times 3 times 3. So when this multiplication is carried out, 5 times 5 times 5 gives 125 plus 3 times 3 times 3 times 3 gives 81, and the result of 125 to 81, 602. That gives us 206. So we've done what we are expected to do here, but what now follows is we want this result to be in base 2, except if it is stated otherwise. So if not stated otherwise, we are going to assume that the result must be in base 2, and for the result to be in base 2 means we are going to do what follows now. So we want it to be in base 2, so basis of division is going to be 2, while this last column will represent what? Our remainder. So 2 into here gives 1, 2 in 0 here is 0, 2 in 6 here is 3, that means remainder there is 0. We divide with 2 once again, 2 in 10 here gives 5, 2 in 3 here gives 1 with the remainder of 1. With 2 again, 2 in 5 here gives 2, 2 in 11 here gives 5 with the remainder of 1. 2 in 2 here 1, 2 in 5 here 2 with the remainder of 1. 2 in 12 here is 6 with the remainder of 0. 2 in 6 here is 3 with the remainder of what? 0. 2 in 3 here gives 1, that one leaves the remainder of 1, and 2 in 1 finally gives 0 with the remainder of 1. Therefore, what we are asked to do, 101 base 2 cube plus 11 base 2 raised to power 4 is equal to, we are going to 1100 base 2. So this also completes the solution to that question. Now I think with this level, with what we have done so far, a good student shouldn't have any form of challenge or problem. But we are going to take one more question that's going to be the last question in this course, and the question is this. The question is, simplify 11 base 2 multiplied by 1011 base 2 minus 111 base 2. So this involves multiplication as well as subtraction. Rule of BODMAS can be applied. So when we follow the rule of BODMAS, we know multiplication we have to come up first. So to multiply is to say that 1011 multiplied by 11. Remember, everything is in base 2. 1 times 1 1, 1 times 1 1, 1 times 0 0, 1 times 1 1, 1 times 1 1, 1 times 1 1, 1 times 0 0, and 1 times 1 1. So what follows this is the addition. We have 1. Remember, everything here is in base 2. It means that any addition that is equal to 2 or higher than 2 will not be written here, but rather be treated somewhere else. Now 1 plus 1 here is 2, so 2 is too big for me to be written, so that has to be 2 divided by 2. 1 remainder 0. I will put down my 0, the 1 will be added to this. So 1 plus 0 plus 1 gives 2, so that is the same thing as 2 divided by 2. 1 remainder 0. The remainder of 0 will be written, while this one will also be taken in here. So when I add 1 plus 0 also gives 2. So 2 divided by 2 is 1 remainder 0. I write 0. So the 1 will also be moved to this place, making to 2 divided by 2 here is 1. With the remainder of 0, the remainder will be written, since I have nowhere to carry my 1 again, so I won't have choice other than to put it here. And we are told that after we multiply, we should subtract. We should subtract 1 1 1. So 1 1 1, and principle of subtracting will have to be applied here. So 1 minus 1 here gives 0, but 0 minus 1 here is not possible. We have to run to the nearest number to borrow 1. So when we move here, we borrow this, it becomes 1. So the series will continue until you get here. So this is now going to be 2 plus what I have here. So 2 minus 1 here gives what? 1. And we can see that when I borrowed 1 here, it became 2. So this one has to leave 1 out of it. So this is 1. So this is 1, this is 1. So 1 minus 1 here gives 0. This, what we have here is 1, since we have nothing to subtract from it. And what we have here is as well 1, since we have nothing to subtract from it, everything base 2. So therefore, The result of multiplying and subtracting, that is 11 base 2 multiplied by 1011 base 2 minus 111 base 2 is equal to 11010 base 2. So this is the final how far we can go with this topic. So I hope to meet you all in the next video when we shall be talking about another topic. So thanks for joining this class.